Get started. Thanks everybody for coming to this talk. We're going to, given that Google is talking about buying mini nuclear reactors to fund their cloud computing centers and other nonsense, it seems that talking about sustainable software engineering is probably and given the madness of the weather outside, probably a timely conversation. Paddy and Karl from Liberty IT are going to come and talk to us about that, so please give them a warm welcome.
Thank you, folks. Yeah, what a morning. I feel like I had to get ready in the dark. My electricity was out this morning, so I feel a bit self-conscious, like I look like I got ready in the dark. But my wife had to do the same thing as well, so there's wee small things that sort of make you smile. I was walking about the house this morning, remembering that scene in Simpsons where he invented a makeup shotgun when my wife was putting her makeup on, so I don't know what. I didn't see what the end product was, to be quite honest. I didn't want to stick it out. So yes, so we're here to talk about scaling the sustainable software engineer mindset. It's just myself and Karl. Karl's a senior portfolio architect with Liberty IT, and I'm a senior software engineer. Formerly an environmental engineer as well, so that's where the passion for sustainability and environmental good governance comes from. Just a quick bit about Liberty IT before we get started. So we are part of the larger Liberty Mutual organisation. That's an organisation with 50,000 people, and representation in 29 countries. So Liberty IT, we're basically, our home is within the Liberty Mutual Tech, which is about 5,000 employees, and we're about 700, we make up about 750, so about 15% of that there. One of the things, as much as a great opportunity to advertise the great company I work for, but it's also just for us is to give an idea of this potential scale of impact. If we get sustainable software engineering incubated well and scaled out throughout the organisation, there is for us a potential to make a very tangible impact. So even within Liberty IT, we have the Green Scene Employee Resource Group. So we're essentially a volunteer-led advocacy group encouraging environmental good practice and sustainability. And environmental engineering has been a focus of ours and one of the focus areas of ours for the past couple of years, really. So a sustainable software engineering mindset. I'd even attempt the Belfast accent. Here bears me what is that about, really? I kind of really, just you're probably looking at the title thing, what are we talking about, sustainable software engineering mindset? And really that's to encourage the development of a sustainable first approach to the software development lifecycle. And there's really two facets to that as well. So each and every one of you at an individual level has the ability and some maybe even say a duty to sort of think about sustainability and try and scale that across your organisation, among your colleagues, encourage people to think about sustainability when they're going through the sustainable software engineering lifecycle processes. But there's also that corporate level as well. So if you think at the corporate level, if you adopt sustainable software engineering as one of your core engineering principles, then there's the ability to really let that filter through your organisation and see the impacts is quite large. So we're going to tell the story in two parts here. I'm going to talk about how we at Liberty IT are trying to leverage some of our existing processes and frameworks to try and encourage the development and proliferation of that sustainable first mindset. And then Karl is going to talk about what tools and frameworks are out there at the minute that you can go in on your office on Monday and start to leverage from the days whenever you sit down. So I don't want to sit and dwell on climate change and what's happening out there, because it is happening. So really, this is a talk about kind of what we can do and what positive impacts we can have. But we still need to impress upon people that as software engineers, we do have an impact. The activities that we carry out does have an impact on the environment and climate change. So why would a middle-aged, not old, maybe a middle-aged man like myself be yelling at the cloud? It is fantastic. It does facilitate. Like so many advances, it's been fantastic in terms of leveraging the cloud-hosted services, data persistence, all that there. It really is fantastic. But with the proliferation of that, there is an impact as well, a cost, financial cost, but also cost to the environment. So data centers, really, it's the energy they use and the emissions associated with that there is the biggest impact. And they account for about 1% to 4% of global emissions. And it's hard to pinpoint exactly, but it seems to be trending towards that 4%. And as I said, you can see in terms of the graphic there, it is going to actually probably proliferate even more with the onset of AI and machine learning processes. And just to put that into context, the big bad wolf of sustainability and environmental impact, airline travel, accounts for 2%. So data centers is actually a bigger impact. As software engineers and software professionals, what's that got to do with us? We sit and we write code. What's that really got to do with us? it's pretty much got a lot to do with us, to be quite honest. So at Liberty IT, we're pretty much we exclusively, mostly exclusively use AWS services, leverage AWS services, and even they operate under a shared responsibility model. So they say, listen, we're going to be responsible for the sustainability of the services we provide, but it's still an onus on you folk to think about sustainability when you're leveraging them. It's even things like, this feels like it's shoehorned in, but it's just such a staggering statistics. Even processes like 68% of data we persist is not touched after we persist it again. It's not touched at all. Think about the financial costs, the cost of the environment, emissions. So we're at the front line of this, to be quite honest. So what are we going to do about it? Well, sustainable software engineering is essentially the vehicle for us to think about how we're actually going to reduce our carbon emissions, reduce our impact. And sustainable software engineering is essentially engineering excellence. It's really rooted in our core engineering principles, but it's an intentional approach to sustainable software engineering. So, for instance, Liberty IT, when I just joined, there was a serverless first mantra about 5 or 6 years ago, probably largely driven to reduce costs and leverage the benefits of the cloud, but there would have been a positive impact in terms of reduction of carbon emissions unintentionally. Turn that on its head, think sustainability first. You're going to deal with the carbon emissions, cost, reliability, all those facets of cloud services, by having that sustainable software engineering mindset as your primary focus. As I said, it's cross-cutting, deals with cost, reliability, security, and essentially it enhances the skill and the ingenuity of engineers. We're engineers, we love to innovate, we love to find a challenge and think how we can do more with less. So going about it, education, just that list I showed of the 3 core principles, education is the first step. Find out for yourself what's going on, why we need to do this, what's happening. This particular course here, Green Software for Practitioners course, it's run in conjunction by the Linux Foundation and the Green Software Foundation. It's free, gives a great grounding on core engineering principles. For us, we at Liberty IT, we have a high-performance engineering framework, which I'm going to talk about in a wee second. But the curriculum and the practice library we have that leverages and underpins that is actually really essential for establishing a good basis of those core engineering principles, which are rooted in sustainable software engineering. In terms of processes, as I said, Liberty IT have the HPE framework, and it's essentially a framework for continuous improvement. There's 12 focus areas that are designed to help teams really continually improve and progress their ways of working. Those 12 key areas really, again, are rooted in your core engineering principles, which are in turn linked back to your sustainable software engineering core principles as well. This is a focus on how you build things. Again, this is the link between processes, knowledge, and information, and this is the practice library essentially just that backs all that up. Observability is the last core principle, really, where you need to have an idea of what's going on so you can take a data-driven approach to making decisions which are hopefully going to reduce the impact. So this is based on the well-architected framework. It's a well-architected framework, for those who don't know, describes architectural best practices for designing and running application workloads. And Liberty IT have extracted the core principles of that there into an observability framework to help provide and encourage observability across those 6 pillars, of which sustainability is one. And this really focuses on what you've built, and again, facilitates a data-driven approach to sustainability. And you can see here the crossover again between observability and our engineering excellence framework. And just finally, before I hand you over to Karl, observability matters, and just across all key pillars as well, really. So if you don't have direct data relating to your carbon emissions, think about what else you can use here. We had a situation where data was being persisted and the audit deletion process didn't work. Cumulatively adding data to our repository, our data store, 3 terabytes of data was there we didn't need, but also there's the financial cost as well. So I'm going to hand you over to Karl. Karl's going to talk about the processes right there that you might be able to leverage from day one, really. Thank you.
All right, so there are things out there already. So Liberty's great. We've got loads of support from the enterprise. We've got all these tools and techniques and processes and frameworks that we can leverage, which is great. But what can you do on Monday, right? When you start to think about sustainability and how you're going to apply sustainable software engineering practices, where can you start? So where you start is with a sustainable software engineering strategy. So this is where you come together as a team, and then you discuss what does sustainability mean to you as a team, right? You're going to set goals, you're going to set targets, and then you're going to figure out ways to reach those targets, okay? And you're going to leverage 3 different frameworks. 3 different things that are out there, all ready for you to take and leverage right now. So Paddy talked about the Green Software Foundation. That would have guidance, training, principles, practices, and patterns on how to design and build and run green software. Then you talked about as well, Paddy, the well-architected framework. There's AWS, Google have one, Azure have one, and that's to help, cloud architects build secure, high-performing, resilient, and efficient infrastructure for a variety of different applications and workloads. So just by following that, you're already optimizing within the cloud, et cetera, and that makes for a more sustainable approach to building your software. And then there's space. And try not to get too freaked out by the space piece. It's quite new, but it's a framework to measure development team productivity. Productivity is it's a hot topic at the moment. And typically what you'll find is a lot of companies focus on performance aspect of it and outputs, lines of code, number of PRs, things like that, heaven forbid. But what the space framework is attempting to do is bringing these 5 dimensions across: satisfaction and well-being, performance, activity, communication and collaboration, and efficiency and flow, to give that holistic view of how teams come together to build software and how they can optimize throughput from concept to cache and minimize waste along the way. So this will prove to be important later on. So you're looking at tools and applications and software, et cetera, and how you build it and design it, et cetera, and then how teams and how we come together and how we collaborate, et cetera, in order to build those things. All right, so let's have a look at the Green Software Foundation here, the principles that they have. And the principles are basically a core set of competencies needed to define and build and run and design green software, which is great. They have a bunch of patterns up on their website as well. And the patterns are a catalog of how to apply these green software principles in a vendor agnostic way. And then, of course, there's practices which you'll have to come up with yourself, which is basically applying those patterns in a vendor specific way. So they provide the principles, they provide the patterns, they provide all of the training materials, et cetera. They even have, training. It's fantastic training on understanding carbon emissions, energy efficiency, et cetera. And you can get certified on that too. So let's talk about some of the green software principles. So energy efficiency, we're talking about consuming the least amount of electricity possible, right? Being optimized in your use of electricity. Hardware efficiency, this is an interesting one. I didn't realize, I didn't understand and appreciate the embodied carbon. So your workloads are going to run on hardware. A lot of energy went into creating that hardware and the manufacture of that hardware. So you're going to try to maximize the utilization of that hardware so that you can spread out the carbon emissions that were used in the making of that hardware over the lifespan of that hardware. And then carbon awareness is great. This is about doing more when the electricity is clean and less when it's dirty. So what are you doing about where and when you run your workloads to take advantage of renewable sources whenever you can? Okay. So here are some of the patterns. I just picked a few. The website's full of them. It's a fantastic resource to go in there and see what kind of things you can do to get an awareness of what actions that you can take. So it goes across artificial intelligence, cloud, web. And you can see here more energy efficient AI and ML frameworks. So you're going with more energy efficient. You're going to take the hit on that rather than high performance. That's part of your sustainability strategy. Leverage pre-trained models, fantastic, because you don't have to go in and train the models from scratch. You can leverage things that are already there. Cost optimization and also sustainable and carbon emissions optimization. Cloud true to the region that's closest to users. This is all pretty obvious stuff. Containerize your workloads. Containerization means that you're able to move those workloads, different regions, et cetera. You're able to scale them out, scale them back down. Containerization is obvious, but you can see the sustainability angle to it from that perspective. And then delete unused storage resources. So all that data that's not getting used, or you have data retention policies, et cetera, delete that stuff back. And you free up your storage and lower your costs at the same time. And in the web, avoid chaining critical requests, parallelization, minify web assets. We've had great success with compacting and tree shaking of our dependencies, et cetera. And that leads to performance gains and also build, test, et cetera, so you can get those fast feedback loops and improve your flow, so the throughput of getting value into the hands of users. And then optimizing image size, which is a really critical thing these days around WebP etc., and different formats that are out there. The other aspect of this, of course, is the well-architected framework that Paddy was alluding to. So if you're following these, you're already on that path towards sustainability and optimization within the cloud and your workloads. Around cost, definitely. But it's the sustainability pillar here that we're really interested in. So if you look at the design principles around this, it's understand your impact. That's the metrics and observability that we talked about before. It's establish your goals, right? So what are your KPIs? What are you working towards that you want to meet? And then you have maximize utilization as well, which is, that embodied carbon into your hardware and infrastructure. And the rest is adopt new hardware, Graviton CPUs, more efficient hardware, etc., going forward. And using managed services where possible, because managed services, they will be being designed with sustainability in mind and optimized over time, and you automatically get the benefit of that. All right, and then reduce downstream impact of your cloud workloads. That's an important one in the sense that you want your users to be able to use your software, your websites, etc., on old hardware that they want to extend the life of that hardware. All right, devices, etc. And then we'll talk about the well-architected sustainability best practices. So you see here the region selection, obviously choose your region based on the business and sustainability goals as well. So not just about business, you're bringing that perspective of sustainability into it. Where can you run these workloads for sustainability, and you have that crossover. Alignment to demand, really important with that scaling to meet demand and being effective in that scaling. Aligned to SLAs. You don't want to over-engineer, you don't want to under-engineer, you want to get it just right. And that means understanding your application, understanding your users, and understanding how your application is getting used. Limit network resources. Do you really need the high bandwidth? Do you really need to autoplay that video, etc.? And then, of course, remove the unused assets. So with software and architecture, they talk about load smoothing and high utilization. Again, that's that embodied carbon. And then you talk about being able to load balance effectively so that customer experience doesn't drop, but at the same time, you're maximizing utilization. And then we see the retire components over time. So get rid of old stuff that you're not using. Prune, clean, and optimize. Data management, you're reducing your provision storage. Do you really need to save all that data? And then you have the life cycles where you have retention policies, etc., and then you have different tiered storage mechanisms which allow you to save costs, but also reduce your carbon emissions over time, and of course delete that data. And then hardware and services, you just thinking about optimizing your hardware to provision and deploy an efficient hardware and services over time. And then it gets back to the space framework, which is process and culture, so you're optimizing your development, test, and deployment practices. Very important. So here are some of the metrics that you're going to look at. Cost, obviously, is available to you right away. That's a good indicator of sustainability. If you're using more CPU, memory, data, network, that's going to be higher cost, but it's also going to be higher carbon emissions. So that's a good way to detect it. Next one is utilization. Obviously, if you have your workloads, make sure that they're well high utilized. So much better to have one server with 100% CPU utilization, for example, or close to, rather than 5 with only 20 because of the embodied cost. Greenhouse gas emissions, scope 1, 2, and 3. These are more for reporting, Fortune 100 companies, etc. They would use this kind of thing at a company level. They're not really useful for us application developers. Much better to use the software carbon intensity metric that the Green Software Foundation came up with. This is it here. So basically, it's the energy consumed kilowatts, multiplied by the carbon emitted per kilowatt by your application. And then you add on the embodied carbon, right, of the hardware that went into that. So the manufacturing, the carbon emissions during manufacturing, per OR, which is your functional unit, which is like per API call, per user, per ML run, your model run, all right? So using all of this stuff, you're going to take on an experimental mindset here. You're going to evaluate using your metrics. You're going to identify opportunities where you can tweak and you can improve efficiencies, etc. And then you're going to define your experiment and how you're going to do that. And you're going to take this stuff, you're going to run them, and you're going to start filling in your sustainable software engineering strategy. So the first thing you do is you come up with your guiding principles around energy efficiency, hardware efficiency, carbon awareness. These are the things that are guiding you in your selection of where you're going to make improvements. And then you're going to come up with global patterns around cloud, AI, ML. You're going to use these patterns to apply to whatever it is that you're going to be working on. And you're going to link out to these different practices, right, these different patterns, and you're going to see what kind of metrics that you're going to use in order to effectively implement them. And then you're going to call out your specific workloads and some of the specific optimizations that you're going to do around those in this document. And this is where everything goes, and you're going to link out to the different pieces in order to track this, and you're going to keep a record of this going forward. All right? So now, let's talk about space quickly. So, as I said before, the space framework, it recommends holistically following these 5 dimensions here to measure, understand, and improve developer productivity, right? So it's the way teams work together to achieve a goal, and they look at these different dimensions to look for opportunities to streamline the delivery of software and minimize waste, all right? So this is all sustainability as well. So we're in building their applications, etc. This is the people part, right? So satisfaction, overall well-being, etc. People with good mental health, well-rested, have a sense of purpose, etc. They are going to make better decisions. They're going to be far more likely to make sustainable decisions as they and have more engagement and be more productive, etc. in their building of green software. Performance is the usual one. Most folks they focus on the outputs, but really we're looking at outcomes here. So what we like to look at here is just revenue, right? Customer satisfaction, right? Quality, product quality, right? And code quality there. So with activity, we're tracking the level and types of activities that developers are doing. So we want to make sure, with coding, testing, meetings, and all these kinds of things, are you focusing on the right kind of activities, or you're indexing on activities that are wasteful or more wasteful of your time? And communication and collaboration is that when you're doing these activities and you're working together and communicating and collaborating, that those meetings, etc., are meaningful and they are effective and valuable. So you want to reduce the meetings where everybody's there, they don't need to be there. Do we have the right people in the room, the decision makers, etc.? So, and then we have the last one, which is efficiency and flow, and that measures the smoothness and effectiveness of the development process from ideation to deployment. So from concept to cache, how easy to get the flow through. It's not just teams pick up a ticket, get it done, throw it out into production. It's about that whole process and trying to minimize waste over time. So sense of purpose, speed and execution, more focus on the right activities, effective communication, and efficiency of flow. These are all sustainable software engineering principles and practices. I can't continue without talking about DORA. These are fantastic metrics to get started on. They cover across various of the 5 dimensions in space: deployment frequency, lead time for changes, change failure rate, and time to restore. As you make improvements, you will see improvements in these scores, or you should do. So as you doing your experiments, these are the ones to look out for, and they're a good place to start. Other than that, we have loads of different metrics that we can tie into and leverage. So satisfaction, well-being, team pulse survey, right? You see the sleep score. That is a thing, right? Between work-life balance, sleep score, how well rested are you? How good is your work-life balance? How fresh and engaged are you when you come to work every day? Innovation time, very important, and growth opportunities. To get time to move away from just doing tickets all the time, to innovate, to get, to handle tech debt and feed that back into the loop. Performance is the same. I mentioned before customer satisfaction, revenue, app performance, product quality, activities, right? Number of stories, PRs, builds. I know counting things is that's why you need to look at this holistically. It's not just counting things, but you start to get an idea where you're spending your time. And then where you're spending your time, are you getting quality out of that time? That's where communication and collaboration comes in here. Cut the meetings you don't need. Maybe there's ways that you can optimize on sending a delegate from a team to meetings for representation. And efficiency flows, throughput, lead time for changes, it's deployment frequency, it's all cycle time, all of these things. These are just a small subset of the different metrics. You choose the metrics that have value to you. You use those metrics to come back to your experimentation mindset and approach. Evaluate using metrics, identify opportunities, and then take action on them. And as you take action, we're going back to our sustainable software engineering strategy. We're going to add in our growth opportunities here seize growth opportunity for a team to skill up and improve over time, and effective meetings that we talked about before. And then you see the satisfaction and well-being below here, where you have that dedicated one-day per sprint innovation time for teams. And then you should see that manifest in your team pulse survey and then your DORA metrics, for example. And then your communication collaboration. And that would be about rotating the team member, to represent your team in meetings outside of your team. And then you're going to take all of these as you go along, the metrics, and you're going to add them to a dashboard. So this dashboard includes satisfaction, well-being, performance, activity, communication, collaboration, all the metrics that are valuable to the team. This is where you're going to track them, and you're going to see them trend over time. And then you're going to be able to see outliers, and you're going to go in there and you're going to understand where to make further tweaks. And you're going to be having, metrics like cost will be going in here. Your carbon emissions, if you're lucky enough to have a carbon emissions tool, the Green Software Foundation have an open source tool that's out there to help you measure the SCI and the emissions of your workloads over time, which is great as well. And then you're going to use these to optimize your team performance in your applications over time. So key takeaways from this is education and guidance. Use the Green Software Foundation, right? They have fantastic education and guidance on carbon emissions and the kind of steps that you can take in order to start tackling those things. You're going to use a data-driven approach in this, so you're going to use observability across all those different metrics and the things that matter to you as a team. And then you're going to use that process-driven approach to agree amongst yourselves, what does this mean for the team? How are we going to tackle these things? And you're going to link off to all the different strategies that you have. Testing strategy, you're going to have a generative AI strategy, you're going to have Copilot strategy, all these different deployment strategies, etc. And you're going to use that then to drive this machine of improvement over time. And remember your core engineering principles. If you're here today, you're obviously here because you want to improve, right? That's exactly the kind of spirit. So continuous improvement, continuous optimization around how we do our work, core engineering principles and practices. You're already doing sustainable software engineering. You just need to take that specific intentional view on how this applies to your work, and then you can drive everything and all your activities off it from that central point. That's it. So I think...
Any questions for Paddy or Karl? Yep.
Hi, so I'm actually an associate software engineer at Liberty. That's a lot of information. In terms of grassroots, starting your career, what resources do you recommend to start thinking about how we engineer software sustainably?
The Green Software Foundation course, they have a practitioner course. It is most enlightening. You go in there, and that's a great place to start.
Brilliant, thank you.
And just as I said, it's your core engineering principles. It's kind of the stuff you learn from day one at university. It really is. So it's really just be rooted in, as I said, your core engineering principles. That's the key thing, really.
Yeah, you'll be really surprised. You go in there and you look at that information, and you'll quickly realize that just by becoming a better developer, you're already on this path.
Brilliant, thank you.
Have you experienced any challenges or any pushback from kind of any of the partners you've worked with, especially as it pertains to things like generative AI, where there's a lot of people who would like to see that in their products, even when it doesn't always make sense there? And maybe how have you handled that if you have encountered that?
That's very interesting. Yes, pushback most certainly. This is why we are taking the approach that excellent engineering, high-performance engineering, is sustainable engineering. So you're doing that and improving, you're already doing this, and it's an easier sell that way, right? It's because you can do both and save the planet while you're at it, right? Become a better developer. Regarding generative AI, yes, most certainly the hype is alive and kicking. With generative AI and our AI, we have standards and practices that we're bringing into our organization to optimize across that. So we have to be deliberate, and you have to be able to demonstrate the value that these things provide before you can go ahead and complete implementation. We do experiment, though, in order to understand whether there is value there in the first place. But our standardization and practices around that really, really help us, eliminate waste where we can.
Just, yeah, that's about how you frame the conversation as well. So for us, when we were having the conversations with the business folk, it's really the benefits in terms of cost rationalization, performance, rationalization, all that sort of your key metrics and seeing the improvements across that board. That's where observability comes in as well, really. So you can actually then demonstrate that and take a data-driven approach, not just your sustainable software engineering decisions that you make as an engineer, but also then take a data-driven approach to how you have those conversations with the decision makers, really. So that's kind of really a key thing.
Yeah, and so what we do in our group is we would come in and we would try to influence the group with coming up with the standards and the approaches and the practices and patterns for AI, right? And we would try and bring in some of these different practices around using energy efficient frameworks rather than having the best and fastest based on the business context, and also being able to train these things in different regions to take advantage of renewable resources. These are things that you wouldn't necessarily just come to mind. It wouldn't be a first-class citizen of your mind, right? So we are in here to help influence and bring that perspective of sustainable software engineering to these kinds of initiatives, practices. Good question, though.
Thank you for the talk. You might be familiar with Goddard's law. If a measure becomes a target, it ceases to be a good measure. So how do you prevent people from optimizing for the metric rather than the underlying idea?
So you see the space framework where you're trying to draw it all together and you've got that flow from concept to cash? It's good to keep an eye on the value that's going on. At the end of the day, we're trying to provide business value. It's a product mindset. If we're not providing value, that's waste. All right, so if you can continually evaluate the features that you put out there, success criteria for those, and if they're not being utilized or they don't meet success criteria, that you are removing them again, pruning, then you're optimizing as you go. So you have to be continually going in and taking a proactive approach to looking at your observability and your metrics to start seeing those things, outliers, anything that you can prune. And some metrics won't be valuable to you over time based on where you are, and some will be more valuable. So it's a constant re-evaluation of your processes and practices.
I think that's everything. Thanks so much, Paddy and Karl.